This is SpaceTime Series 28, Episode 55, for broadcast on the 7th of May 2025. Coming up on SpaceTime, how giant exploding stars make uranium, shattering long-held beliefs about the main-belt asteroid Vesta, and a new study resolving the question of whether it rained or snowed on ancient Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has provided fresh clues explaining how exploding stars produce uranium and other heavy elements by quite literally dissolving into neutrons. Understanding the origin of heavy elements on the periodic table is one of the most challenging open problems in all of physics. We know that all the elements other than hydrogen and helium and small amounts of lithium and beryllium, which were created in the Big Bang 13.8 billion years ago, are created in stars, either during their lifetimes as they evolve or through spectacular supernovae as they die. In the search for understanding the conditions suitable for creating these elements through nucleosynthesis, scientists are now going where no researchers have gone before. They're looking at gamma-ray burst jets in the surrounding cocoon emerging from collapsed stars. A report in the Astrophysical Journal suggests that high-energy photons produced deep inside gamma-ray burst jets could dissolve the outer layers of a star into neutrons, causing a series of processes that may well result in the formation of heavy elements. One of the study's authors, Matthew Mumpower from the Los Alamos National Laboratory, says the creation of heavy elements such as uranium and plutonium necessitates extreme conditions. The thing is, there are only a few viable yet very rare scenarios in which these elements can form, and all of these hypotheses require the need for copious amounts of neutrons. So Mumpower and colleagues are proposing a new phenomenon whereby those neutrons don't pre-exist but are produced dramatically by the star itself. Free-flying neutrons have a short half-life of just 15 minutes. That limits the sort of scenarios in which they're available in the abundances needed to form heavy elements. Now, the key to producing the heaviest elements on the periodic table is known as the rapid neutron capture process, and it's thought to be responsible for the production of all the naturally occurring thorium, uranium, and plutonium in the universe. The author's framework takes on the challenging physics of this process and then resolves it by proposing reactions around the star's collapse, which could result in heavy element formation. In addition to understanding the formation of heavy elements, the proposed framework also helps address critical questions around neutron transport, multi-physics simulations, and the observations of rare events. Now, in this scenario Mumpower proposes, a massive star begins to die as its nuclear fuel runs out. Eventually, the balancing act between the outward push of nuclear energy as the star burns fuel and the inward pull of gravity comes to an end, and gravity wins. No longer able to push up against its own gravity, the star collapses, forming a black hole at its center. Now, if the black hole is spinning fast enough, frame dragging effects from the extremely strong gravitational field near the black hole wind up the magnetic field and launch powerful jets. Now, through subsequent reactions, a broad spectrum of photons are created, some of which are at very high energies. That includes gamma rays. Mumpower says these photon jets blast through the star ahead of it, creating a hot cocoon of material around the jet, sort of like a freight train ploughing through snow. At the interface between the jet and the stellar material, high-energy photons can interact with atomic nuclei, transmuting the photons into neutrons, literally turning energy into matter. Now, existing atomic nuclei may also be dissolved into individual nucleons, creating more free neutrons to power the process. The calculations suggest the interaction with light and matter can create neutrons incredibly quickly, on the order of a nanosecond. Now, because they're charged, protons get trapped in the jet by the strong magnetic fields. But neutrons, which are chargeless, are ploughed out of the jet into the cocoon. Having experienced a relativistic shock, the neutrons are extremely dense compared to the surrounding stellar material, and therefore a rapid neutron capture process could occur, with heavy elements and isotopes being forged and then expelled out into space as the stars ripped apart. The process of protons converting into neutrons, along with free neutrons escaping into the surrounding cocoon to form heavy elements, involves a broad range of physics principles and encompasses all four fundamental forces of nature. a true multiphysics problem combining areas of atomic and nuclear physics with hydrodynamics and general relativity. But more challenges remain, as the heavy isotopes created during this rapid neutron capture process have never been produced on Earth. Researchers know little about their properties, such as their atomic weight and half-life. Still, the high-energy jet framework produced by the authors may help explain the origins of kilonova, a glow of optical and infrared electromagnetic radiation associated with long-duration gamma-ray bursts. Kilonovas have been primarily associated with the collision of two neutron stars, or through the merger of a neutron star and a black hole. Now, these intense collisions are one possible method for confirming with observations the cosmic factories of heavy element formation. But star dissolution through high-energy photon jets offer an alternative origin for the production of heavy elements and the kilonovae they may manufacture, a possibility not previously thought to be associated with collapsing stars. As a side note, it's worth remembering that scientists have observed iron and plutonium in deep-sea sediments. These deposits are known to come from extraterrestrial sources, though as with the phenomena producing kilonovae, the specific location or cosmic event remains elusive. So the collapsar high-energy jet scenario represents an intriguing possibility as the source for these heavy elements found deep under the sea. This is SpaceTime. Still to come, shattering some long-held beliefs about the asteroid Vesta, and a new study has supported the long-held scientific view that geological formations seen on the red planet Mars were formed by water and snow billions of years ago. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by our official virtual private network partner, NordVPN, the one we trust and the one we use right here on this show. Whether you're tuning in from your favourite cafe, an airport lounge, or just your living room, one thing's clear, the internet isn't always as private as it seems or as it's supposed to be. In fact, every click, every login, every connection you make can leave you exposed if you're not protected. Whether you're browsing, streaming, shopping, or just checking email on public Wi-Fi, your information is vulnerable to snoops, to trackers, and of course to hackers as well. And that's where NordVPN comes in. It's your first line of defense. It encrypts your internet connection, keeping your data safe and your online activities private, even on unsecured networks. It also lets you access content from around the world, bypassing regional restrictions. So no more geo-blocking. And also it helps avoid annoying bandwidth throttling. We use it every day here on SpaceTime, and it's not just about security, it's about peace of mind. And right now, SpaceTime listeners can get an exclusive deal, up to 74% off a NordVPN plan. Plus, you'll get 4 extra months for free on top of that. And of course, it all comes with a 30-day money-back guarantee, so you can try it out completely risk-free. Just visit nordvpn.com/StuartGary to lock in your free offer today. That's nordvpn.com/StuartGary, or use the code StuartGary at the checkout. Stay curious, stay protected with NordVPN. And now, it's back to our show. A new study suggests that the mysterious world of Vesta is really just a big asteroid. The findings, reported in the journal Nature Astronomy, show that Vesta's interior structure is far more uniform than previously thought. The discovery has shocked many researchers who until now assumed Vesta was a protoplanet that never grew to its full potential. For decades, scientists believed that Vesta, one of the largest objects in the main asteroid belt between Mars and Jupiter, wasn't just another asteroid. They concluded that Vesta had a crust, a mantle and a core, and they're the fundamental properties of celestial bodies like planets. So astronomers have been studying Vesta for clues as to how early planets grew and what the Earth might have looked like in its infancy. One of the study's authors, Seth Jacobson from Michigan State University, says the lack of a core in Vesta was really quite surprising. So, what was Vesta's true identity? Well, the authors have come up with 2 hypotheses that need further exploration. The first is that Vesta went through an incomplete differentiation, meaning it started the melting process needed to give the asteroid distinct layers, like a core, mantle and crust, but it never finished them. The second, which Jacobson first floated at an astronomy conference years ago, is that Vesta is really just a broken chunk off a growing planet. Jacobson wanted other researchers to consider the possibility that some meteorites could be debris from collisions that took place during the planetary formation era 4.6 billion years ago. He says that idea went from a somewhat silly suggestion to a hypothesis that astronomers are now taking seriously due to a reanalysis of data from NASA's Dawn mission. See, most asteroids are made of very ancient chondritic material, appearing like cosmic sedimentary gravel. Now, in contrast, Vesta's surface is covered in volcanic basaltic rocks. And these rocks indicated to scientists that Vesta went through a melting process called planetary differentiation, where the metal sinks to the center and forms a core. NASA launched the Dawn spacecraft in 2007 to study Vesta and Ceres, the two largest objects in the main asteroid belt. The goal was to better understand how planets formed. Dawn spent many months in 2011 and 2012 orbiting Vesta, measuring its gravitational field, taking high-resolution images, and creating a very detailed map of its surface. It then performed similar tasks around the dwarf planet Ceres, the mission finally reaching an end in 2018. Jacobson says the more they used the data, the better they got at processing it, and they found ways to more accurately calibrate measurements, yielding an improved picture of Vesta's makeup. Eventually, they decided to reprocess Vesta's measurements. But for years, conflicting gravity data from Dawn's observations of Vesta created puzzles. After nearly a decade of refining their calibration and processing techniques, they finally achieved a remarkable alignment between Dawn's Deep Space Network radiometric data and onboard imaging data. The authors were eventually able to show that Vesta's history is far more complex than previously thought, and it was shaped by unique processes like interrupted planetary differentiation and late-stage collisions. Planetary scientists can estimate the size of a celestial body's core by measuring what's called the moment of inertia. It describes how difficult it is to change the rotation of an object around its axis. Jacobson compared the concept to a figure skater spinning on ice. They change their speed by pulling their arms in to speed up and moving them outwards again to slow down. So their moment of inertia is changed by changing the position of their arms. Now, in a similar way, an object in space with a larger core is a bit like a ballerina with her arms pulled in. Celestial bodies with a dense core move differently through space than ones with no core at all. Now, armed with this knowledge, the authors measured the rotation and gravitational field of Vesta. The results showed that Vesta didn't behave like an object with a core, challenging prior ideas about how it formed. Of course, neither hypothesis has been fully explored enough to rule either out, and both have problems that still require a lot more research to explain. Now, while incomplete differentiation is possible, it doesn't line up with the meteorites researchers have collected over time. Jacobson says he's very confident these meteorites came from Vesta, and they don't show any obvious evidence of incomplete differentiation. The alternative explanation is based on the idea that as the terrestrial planets formed, large collisions occurred, mostly growing the planets, but also generating impact debris. Ejected materials from these collisions would include rocks resulting from melting, and like Vesta, they wouldn't have a core. Jacobson's lab's already exploring the consequences of giant impacts during the planetary formation era. He's now working on the idea that some asteroids in the main belt are pieces ejected from the growing planets. But the idea is still far from proven. More models need to be created and fine-tuned to prove that Vesta is an ancient chunk of a forming planet. Jacobson says the paper's really only the beginning of a new direction of study that could forever change how scientists look at differentiated worlds. No longer is the Vesta meteorite collection simply a sample of a body in space that failed to make it into a planet. Instead, they could be pieces of an ancient planet before it grew to full completion. Scientists just don't know which planet yet. The answers may be contained in the Dawn data. This report from NASA TV.
You know, when you work on a mission this long, it feels like a part of you. I've been a space enthusiast since I was 4 years old. Getting to work on a mission like this it's a dream come true. To me, Dawn is truly Earth's first interplanetary spaceship. No other spacecraft has gone to a distant body, gone into orbit around it, maneuvered there, then broken out of orbit, traveled elsewhere in the solar system to another alien world, and gone into orbit around it. And it does that with ion propulsion, which I first heard of in a Star Trek episode. We've turned ion propulsion from science fiction into science fact.
The Dawn mission really is a journey back to the beginning of the solar system, and that's why we call it Dawn. We chose 2 time capsules from the beginning of the solar system, Vesta and Ceres, which are the most massive and largest bodies in the main asteroid belt. They both formed very early when the solar system was forming out of the protoplanetary disk, and yet they ended up in these 2 very different states. Vesta is a dry, rocky body that looks a lot like our moon, whereas Ceres had a lot of water, and it looks much more like the icy moons of the outer solar system.
And it seems like what determined their eventual fate was the location where they started. And we now believe that Ceres formed much farther from the sun than it is now.
When Dawn found the bright material on Ceres, what we saw was completely mind-blowing. It was made of sodium carbonate. Sodium carbonate is not common in the solar system, but we see it coming out of the plumes of Enceladus. We see it in lakes on Earth, and here it was on the surface of Ceres.
Dawn serves as a lasting reminder that the passion for bold adventures and our noble aspirations to reach out into the cosmos take us far, far beyond the confines of our humble home here on planet Earth.
In that report from NASA TV, we heard from Dawn Chief Engineer and Mission Director Mark Raymond and Dawn Principal Investigator Carol Raymond. This is Space Time. Still to come, did it rain or snow on the red planet Mars? And later in the science report, a new study has found that spruce trees not only respond to solar eclipses, but they actively anticipate when they're about to happen. All that and more still to come on Space Time. Hey there, Space Time listeners, buckle up because I'm about to thrill you and tell you about our new sponsor, Insta360, the wizards behind cutting-edge 360-degree action cameras. Their brand new Insta360 X5, which dropped on April the 22nd, is an absolute game-changer for capturing your adventures, whether you're exploring the cosmos or just your backyard. Now picture this. The X5 shoots jaw-dropping 8K 30 360-degree video, grabbing every angle in one go. No need to fuss with aiming. Just hit record, soak in the moment, and later with your Insta360 Stick mobile app, pick up any perspective you want. This app's loaded with AI-powered tools that make editing a breeze. You can craft epic shots without breaking a sweat. From immersive first-person views to creative third-person angles, this camera does it all. And what's powering this beast? Well, it's a triple AI chip with buttery smooth performance. It's paired with massive sensors and a dedicated low-light mode that delivers stunning clarity day or night. Plus, the X5 lenses are the toughest Insta360s ever made, and they're fully replaceable. So go ahead, take that daring shot with total confidence. To bag a free 114cm invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase, head to storeinsta360.com and use the promo code SPACETIME. But it's only available for the first 30 standard package purchases. And for more information, be sure to check out the links in our show notes. Insta360, brilliant technology for a brilliant camera. And now, it's back to our show. A new study has supported the long-held scientific view that geological formations seen on the red planet Mars suggest that heavy precipitation likely fed many networks of valleys and channels that shaped the Martian surface billions of years ago. The findings, reported in the Journal of Geophysical Research Planets, paints a picture of a world that was relatively warm and wet, very different from the frigid wasteland we know today. The study's lead author, Amanda Steckel from the University of Colorado Boulder, says you can pull up Google Earth images of places like Utah and then zoom out and you'd see similarities to the red planet Mars. Now, most scientists today agree that at least some water existed on the surface of Mars during the Neutron epoch, roughly between 4.1 and 3.7 billion years ago. But exactly where that water came from has long been a mystery. Other researchers say ancient Mars wasn't ever warm and wet, but was always a cold and dry desert. Now, during the Neutron, the solar system's then young sun was only about 75% as bright as it is today. Sprawling ice caps may therefore have covered the highlands around the Martian equator, occasionally melting for short periods of time. So Steckel and colleagues set out to investigate the warm-wet versus cold-dry hypotheses of the past Martian climate. They drew on computer simulations to explore how water may have shaped the surface of Mars billions of years ago. And they found that it was precipitation from either snow or rain which likely formed the patterns of valleys and headwaters that are still visible on Mars today. Steckel says these valleys began in a large range of elevations, and it's hard to explain that with just ice. Now, satellite images of Mars today still reveal the fingerprints of water on the red planet. Around the equator, for example, vast networks of channels spread from the Martian highlands, branching like trees and emptying into lakes, and even possibly a Martian Northern Ocean. In fact, NASA's Mars Perseverance rover, which landed on the red planet in 2021, is currently exploring Jezero Crater, the site of one of these ancient lakes. During the Neutron, a powerful river emptied into this region, depositing a delta of sediment on top of the crater floor. To study that ancient past, Steckel and colleagues essentially created a digital version of a portion of Mars. They drew on computer simulations originally developed for Earth studies, and then used software to model the evolution of the landscape on synthetic terrain that resembles Mars close to its equator. In some cases, the authors added water to that terrain from falling precipitation, and in other cases they included melting ice caps. Then, in the simulation, they let the water flow for tens to hundreds of thousands of years. The authors then examined the patterns that formed as a result, and specifically where the headwaters feeding Mars's branching valleys emerged. The scenarios produced very different planets. In the case of melting ice caps, those valley heads formed largely at high elevations, roughly around the edge of where the ancient ice sat. But in the precipitation examples, Martian headwaters were much more widespread, forming at elevations ranging from below the planet's average surface to altitudes of more than 11,000 feet high. Steckel says water from these ice caps starts to form valleys only around a very narrow band of elevations, whereas if you had distributed precipitation, you can have valley heads forming everywhere. The authors then compared these predictions with actual data from the Martian surface, taken by NASA's Mars Global Surveyor and Mars Odyssey spacecraft. And the simulations that included precipitation lined up more closely with the real red planet's surface data. Now, the authors are quick to point out that these results are not the final word on Mars's ancient climate. In particular, how the planet managed to stay warm enough to support snow and rain still isn't clear. But that's for another paper. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that microplastic pollution is now everywhere. A report in the journal Nature says that most research on microplastics in the ocean is focused on water near the surface. But it says that could compromise a measurable part of the carbon that cycles through the ocean. The authors studied microplastic distribution recorded in different ocean depths at over 1,800 stations around the world between 2014 and 2024. They found that although microplastic pieces decreased in number with depth, they increased as a percentage of total organic carbon particles, from 0.1% at 30 metres to 5% at 2,000 metres in depth. The authors say a more consistent study method and international coordination on monitoring would help clarify exactly where microplastics end up in the ocean. A new study warns that healthcare workers who wash their scrubs and uniforms at home may unknowingly be contributing to the spread of antibiotic-resistant infections. A report in the journal PLOS One looked at how well 6 models of home washing machines decontaminated swatches of a contaminated healthcare worker's uniform using hot water and either a rapid or normal cycle. They found that half of the machines they tested couldn't disinfect the clothes during the rapid cycle, and a third failed to clean the fabric sufficiently even during a full cycle. Additionally, the authors sampled the insides of 12 washing machines for any nasties that could have built up inside them. Not only did they find potentially pathogenic bacteria, but they also found that some had antibiotic-resistant genes. In an amazing discovery, a new study has revealed that spruce trees not only respond to solar eclipses, but actively anticipate them by synchronizing their bioelectrical signals hours in advance into a cohesive forest-wide phenomenon. The stunning discovery, reported in the Journal of the Royal Society Open Science, also shows that older trees exhibit a more pronounced early response, suggesting that these ancient sentinels retain decades of environmental memory and may use that to inform younger trees of impending events. The study adds to the emerging evidence that plants are active communicative participants in their ecosystems, capable of very complex coordinated behaviours akin to those we see in animal groups. Makes you wonder whether lettuce really could scream when you eat it. More than 31,000 passwords belonging to CommBank, ANZ, Westpac and NAB customers have been stolen and are now being shared online by cybercriminals. The passwords were stolen directly from users' devices infected with infostealer malware. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, there were more than 31,000 of these passwords belonging to customers of the big four banks. And not only are these available online and for sale, but they can actually be available free of charge as well, because seemingly they have so many of them. So while some of this information may have been leaked in previous password hacks, in this case, people using Windows computers have been targeted by malware, and this can sometimes be from their kids or themselves looking for pirate content to unlock various games or apps, or just pirating digital media, and somehow they get their computer installed, normally a Windows PC, with malware. And so this infostealer malware would then give the criminals backdoor access into the user's computer. They could use a keylogger to see any changes they were making and even capture the authentication token for when two-factor authentication had gone through, thus able to steal people's money and cause a lot of havoc. You need to make sure that you have solid internet security software, but also, and you should do that anyway, irrespective of your banking login details, but you can also use a different computer device. You can use an iPhone, an iPad, an Android tablet, a Mac, a Linux computer, something else that you've also secured, but iPads and iPhones normally, and Macs are generally speaking, the most secure of all. So if you use a different device for your sensitive logins to superannuation, which got hacked recently as well, and bank websites and other sites that are sensitive, then your main computer, even if it does get affected, it shouldn't affect this other device.
There's been another attack just the other day too, wasn't there?
Yes, this just came out that cybercriminals have stolen nearly 100 staff logins from Australia's big four banks, and obviously that puts those businesses at risk. These are compromised staff credentials now, and according to reports, this can allow hackers to get into initial access of the systems from these banks, and you can be running all the latest software. There are zero-day vulnerabilities that can be at play that allows sophisticated attackers to break into various systems. So, you need to make sure your data is backed up, that all your devices are up to date. In case of some ransomware or other attack, that you've got the ability to do quick disaster recovery and get going again. Otherwise, this sort of attack can shut businesses down.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.